Hello class, good morning. Hello teacher. Have you had your breakfast?
Yes.
So how are you today? Are you feeling good? So last school holiday, where have you been?
Cameron Highland.
Wow, you go to Cameron Highland? You eat the strawberry?
Yes.
How about you, Anis?
I go to the body set.
Wow, with your family?
Yes.
You, Mr.
I went fishing.
You went fishing with your brother. Do you catch a lot of fish?
Yes, very big. Ikan kerapu.
Wow! You have talent, yeah, to fish?
No, my brother caught it.
Okay, class. So, I want to share with you about my vacation too. Last school holiday, my family and I, we went to SCE550 Lake Town Resort. Do you know where is the place located?
Yes.
Where is it?
Really?
That's great. You must be from northern region, right?
Yes, my village. Yes.
So, SCE550 is actually a dam for the Perlis water supply. Have you ever seen a dam before?
Not in the real life.
Not in
the
real-
picture and the video.
Okay, so I will show you a video, a picture of dam. So this is a dam. As you can see in the picture, there is a lot of water here with a very great depth, great height of the wall here, and then there is water shoot out from the dam. And this water will be supplied to the villagers, to the factories, okay? So the structure of the dam will be built in the stream or river side because they take the water from the river, right? And do you know the function of the dam? You don't know?
To store water.
To store water, yes, that is one of the functions of the dam. And then the other function of the dam is to control flooding and generate electricity. Do you have any idea about the electricity generation from the dam? Have you ever heard about hydroelectric? Electricity can be produced from the turbine running around here. That is not our topic today. So, what is this? Do you have any idea what is this picture about? Yes, water shooting out at high velocity at the base of the dam. So let me show you a cross-sectional picture of the dam. Here is the water. This is the wall of the dam. And then at the base of the dam, the water will shoot out. Okay, the water will be discharged here. Somewhere around here, we'll have the valve to control the water discharge. So, do you know why the outlet of the water is near to the base of the dam? Do you know why the outlet of the dam is not located here or here? Why is the outlet is located at the base? Do you have any
Get more
idea?
water.
Yes?
To get more water out.
Get more water out. Good try. But that is not an exact answer. Anyone else? Pressure. Okay, that is what we are going to discover more today. And then you are not very clear about this yet, so it's okay. So we are going to learn about this today. Chapter 2, pressure. I assume you have do your reading before coming to my class? Okay. Yes, a little bit. It's okay, we will go through more today. At least you have get some picture about this topic. Okay. In specific, we are going to look at the pressure in liquids. So our learning objectives today is to communicate about the concept of pressure in liquid with this formula, and then to solve problems involving pressure in liquid. Actual P equals to H rho G plus atmospheric pressure, and then to communicate about the application of pressure in liquid in our daily life. So, as you see on the slide, the formula P equals to H rho G. So this is actually the formula of the pressure in liquid. In liquid, okay? Liquid can be anything. Can you give me an example of liquid?
Water.
Water. Oil. Okay, that's all. Okay, water and oil are the examples that we use in our syllabus. There are a lot of liquid out there, okay? So what is P, class? Pressure. H? Height ataupun depth of water. Wow, seems like you do your homework. What is rho?
Density.
Density. G is gravitational. Okay. So this is a very simple formula. Do you know the SI unit for pressure?
Pascal.
Pascal. Good, Najwana. Pascal. Pascal, like a movie name. So I have a simple calculation to show to you using this formula. I need to write it smaller, or else it will not fit. P equals to H rho G. Let's say, can you turn your textbook to page? Page 48, the formative practice 2.1. This is a very simple calculation, so I assume you can do this. Okay, let me give you an example. Let's say we have a water pressure at depth of 24 meter. Depth is H. H equals to 24 meter. And then the density of water and G. G is constant, your class. In every question you find in your paper or any chapter, gravitational acceleration is always constant. Okay, let's say you have water pressure, you need to find out the water pressure at the depth of 24 meter in the lake, with density of water in the lake 1000 kg per meter cube, and gravitational acceleration of 9.81 meter per second squared. So, do you know? Can anyone calculate this for me? Using this formula.
Can I try this?
Yes. You want to come forward? Yes, correct answer, Najwana. Thank you. Do you guys, Anis and Hawizulin, do you get the same answer with Najwana?
Yes.
Okay, this is in unit Pascal. Alternatively, you can replace this one with kilo. So it will be what? Kilopascal. Okay, let's say I have known the pressure and I want to find the height or the depth of the lake. You want want to know the depth of the lake. How can you find the depth of the lake using this formula? How do you do this? How do you do that?
Just rearrange the formula.
Yes. Just rearrange the formula. Okay. So we want to find the H. The formula initially is like this. Pressure equals to H rho G. And if you want to find the height, you just rearrange the formula into, you leave the H here and then P rho G. Okay. Does everyone get this idea?
Yes.
So, this is not just a formula, okay class? From this formula, you can actually answer questions of application of pressure in daily life. Because from the formula, it already indicates to you the factors affecting pressure in liquid. So, do you have any idea what is the factor affecting liquid in pressure?
The depth of the liquid.
Yes. How do you know that?
The formula.
From the formula, you can know the factor affecting pressure, the depth of the liquid, and then density. So these two are the factors that affecting the pressure. Why does G not affect the pressure?
It's a constant.
Yes, because it is a constant. So when you come across a question that asks you to explain or ask you to define, you can always look back to the formula and you will find the idea. That's the tip. Okay? So, I want to show you a demonstration because the depth of the liquid influence the pressure of water, right? So this is an easy demonstration that you can try at your home with your sisters or brothers. I want to show you. Okay, this water, I have burnt 3 holes here, here, and here, and I want to show you guys the factors of depth. Okay, let's say we calculate the H from here. H is from here, and then this 1, this 2, this 3. Which of these 3 holes have the highest depth? Do you think?
The bottom.
The bottom one, right? What do you think will happen to the distance of the water spurt out? Will it be closer or further from the source?
Further.
Let's prove that. Can everyone see this? Okay. I am excited to show you. From here, you can see the bottom hole will spurt out the most further distance of the water. Comparing to the upper one, it will spurt only a few distance. Because comparing their height, the one who has the highest will spurt out further water. Comparing this one. Okay. You understand what I'm showing? You can try this at home for better understanding. So that is one. And I have another one to show you. That one. We have 3 holes here, and this one will go further due to the height difference. The other demonstration, what the demonstration I will show you a video, is about water with holes at the same level. What do you think will be the distance of the water spurt out? Will it be closer or will it be different?
It will be the same.
The same. Why? Because
Same
you are
height.
very brilliant, yeah. I haven't taught you, but you already know. Because as the hole is at the same level of the water, the pressure experienced at each hole is the same. Because due to the depth of the liquid. Yes, because the depth of the liquid is the same. I have actually have a video for you to watch. The depth of the water spread out at the same distance because pressure is constant. Because pressure is constant at the same level. Another one. To give you another clear picture. If I have a tube of different shape, let's say this one, this one, and then this one will go zigzag. I want to measure the pressure here. Do you think the pressure will be the same or different? Why? Why do you think it is different? This is a very tricky question, but it's not that hard to think. Does anyone have any idea? Because the shape. Are you sure? When you are having this confusion during the examination or test, you get back to the formula. Does the formula mention any volume or shape? No, right? So, okay, again, I asked you, what do you think the pressure of here, point A, point B, and point C? They are at the same level. Does the pressure will be the same or different?
Same.
The same, yes. Now you get the idea because the height is the same. Even though the shape is different, but no, it is not affected by the shape or the volume because it only affected by the height or depth of the liquid and the density of the liquid. Okay, now I want you to take a look on the problem solving section. Turn to page 45 please class. Let's try this together, okay? You have your calculator with you?
Yes.
Good. But this one here, we will take a look on the actual pressure. Do you know what is actual pressure?
The real pressure.
Okay, actual pressure is the pressure when we add atmospheric pressure at the back, at the behind of the calculation. Do remember when the question asks you the pressure experienced by fish caused by water around it. This one, it doesn't mention the actual pressure, right? So, what is the formula for calculating the A? H rho G. Yes, just using the H rho G because it doesn't mention the actual pressure. But if it mentioned actual pressure acting on the fish, you need to add atmospheric pressure value. So what is the atmospheric pressure value? Atmospheric pressure value, which is 100,000 Pascal or 100 kilopascal. This is atmospheric pressure in sea. Okay, in the sea. Okay, so first question, who wants to try? A. Pressure experienced by the fish caused by the water around it. Again, we are using this formula. Pressure equals to H rho G. Pressure is what we are looking for. And then H. What is H, class? Depth of water, which is 1.5 liter. And then the density of water, 1050 kg per meter cube. Good. You remember the unit. Okay. And then gravitational acceleration, as usual, the value? 9.81. Okay, can someone calculate this for me? What is the value? What is your answer?
I get 15,450.75.
15,000? Yes. Correct. Good job. Habis today?
PA.
Pascal. The unit Pascal. Don't forget the unit, okay? Or else your marks will be deducted in test. So, this is very simple questions. Like I said, you just simply put the value and then you just calculate it using your calculator. Very easy, guys. Okay, and then for B, we have to calculate the actual pressure acting on the fish. Remember what I said? When the question is asking the actual pressure, you need to what? Add
atmospheric pressure.
Yes, you need to add atmospheric pressure. So P equals to H rho G plus atmospheric pressure in the sea. Okay? So this part we have calculated. This part we have calculated previously. So just simply put the answer, which is the, again, how is it? 115, 450,
0.75. This is the answer.
For atmospheric, you are very good. Okay, so let me refer my so this is in unit Pascal. If you want to change it into kilopascal, what do? You divide by 1000. So we will get 150.5 kilopascal. Okay, class. So let's move on to the next question. Can someone please calculate this for me?
Using the same formula?
Yes, but with a little modification. Because, okay, let me read the question for you. Figure shows a U-tube filled with water and olive oil. The density of water is 1000 kg per meter cube. Calculate the density of olive oil. Density of olive oil is what we want to find out. So, what is the height of the water column? We will label that as H1, okay? H1, 1 is for water and 2 is for the oil. Okay, height of the water is 15 cm. And then, the density of water as mentioned in the question is 1000 kg. And the height of olive oil, H2, is 16.5 centimeter. So how do we calculate the density of olive oil? Anyone would like to try? Okay,
Can I try?
yes, please come. May I help you, Anis? Thank you, Anis. You get the same answer with me. In this question, somehow, it shows the pressure at point 1 is equivalent to the point 2. So this one is correct. And then Anis wrote the formula for liquid 1 and then liquid 2. And then what we want to find out is the density for liquid 2, the olive oil. So Anis rearrange the formula. And then the G we can be cancel because same value will get 1. Okay? Alright. So substitute the value in the equation and then you will get the final answer. Do you have any question, class?
No, miss.
Good, class. Okay. So, in our daily life, where can you see the application of the liquid pressure being applied to?
Yeah.
There, just like I explained before. Waterfall. Good try. Lagi.
Tank. Water tank.
Water tank, yes.
That's all I know.
That's all you know. It's okay. I will explain to you. Have you, of course you have a house, right?
Yeah.
A house. This is your house. And then we have roof up here. And then between the roof and your house, there will be a water tank here. Some houses, they put the water tank outside of the house. But this one, it puts up here. Why do you think it is? The pipe is here. What to do? Because class, back to our formula. The distance or the height of water tank between the pipe is high. So when the height is high, the pressure will be high too. You don't want your pipe water to run slowly, right?
Yeah.
That's why you place the tank up between the ceiling and the roof. Okay, next example. Oh, I forgot to show you the picture. So this is the picture. It places the tank at the top of the house, between the roof and the ceilings.
The roof is broken, teacher.
Because they want to show you that there is a water tank inside. This is the pipe. Can you imagine if the water tank is placed somewhere around here? Let's say the water tank is placed as like here. What do you think will happen to the water?
Water runs slow.
Yes, it runs slowly. You don't want the slowly. That's why you place it up here. Okay, you understand the concept?
Yes.
Good. Very good. And then the second example, the position of intravenous liquid. Have you ever go to the hospital visiting sick people? Okay. Do you notice that this intravenous liquid bag is placed up?
Yes.
Why? Why do you think it is not placed like next to the pillow or on the patient? Why?
So the liquid will enter the body easier.
Yes, easier because we want the pressure to be high. If the intravenous liquid bag is placed beside the patient while the patient is lying down and the bag is also lying down, then the pressure of the liquid will get into your body slowly. Then you will get slow recover lah. Okay. And then the last example, the last application, as I've mentioned before, the dam, the construction of the dam. There is two things to be considered here. As you can see in the picture, what is the first thing? Here. The top of the wall is much thinner than the base. Right? Why? Because of the? Again, pressure. Pressure is our favorite word for today. And then, why do you think the outlet of the water is at the base of the dam instead of up here? Yes. Okay. Let's see. If the engineer built our dam like this, with the width of the wall same from the top to the bottom, and here is the water level, right? And here is the fish. If the engineer builds the dam like this, what do you think will happen to the dam? Yes, it will break. Because here we have high pressure compared to the upper one. The surface of the water will have much lower pressure. If the pressure is high, then this wall of the dam have the tendency to break down. Then the water will fly away. Okay. So, do you have any question? Do you understand what I teach today?
Yes.
So I will give you a prize because you understand what I'm saying, what I'm teaching today. So please turn up to page 48. I want you to do formative practice. Complete number 1, 2, 3. And then summative practice, page 66. This one just do the problem solving one, number 5. Okay, so sum up what we learned for today. The first thing first, we learn about pressure, of course, pressure. The pressure equals to H rho G. What is H again, class? Depth of water. And then rho?
Density
of water. G?
Acceleration.
Okay, good. What if the question asks us to find the actual pressure? What should you do? Yes, at the atmospheric pressure. No worries, this value will be given in your question paper. And then the third one, we have learned about the application. Can you relate to the application, class?
Yes.
If you want to build a house, would you put the tank on the ground or at the top of the house? Yes, because we want to create high pressure. So I think that's all for today. Do you have any questions again?
No.
Okay, you have been a very good students here today. So thank you, class, and see you all next week.
Thank you, teacher.